Good day. This is Anna Galactic bringing you another science presentation. You're looking at the lab cat. Let's get a look back here at the screen. My name is Scott. I'll be leading you into infinity today in these science broadcasts that have been being produced and uploaded to YouTube for the past 9 months. The theme has been astronomy, to divulge the secrets of the universe, those things about the universe which had not been known a century ago, but now are known, and science would like to understand this new knowledge. In order to understand knowledge, one has to first know what that knowledge is. The subject today is infinity. One of the most baffling terms, perhaps it could be said, the most baffling term that's ever presented itself to the mind of man. Now, in the realm of philosophy, arguments can be raised against practically any statement. It's virtually the job of philosophy to challenge anything in order to get at the truth by means of dichotomization, which is a form of binary approach, having to do, in our case, in science, with logic, which would mean a binary split on true and false. At the limit, we've discovered that is not necessarily the right approach, because true and false tend to merge into a different form of logic called superpositional logic, which, to make a somewhat intricate subject or intricatized subject simple, simply means yes and no logic still applies in superpositional logic, but with an added state that does not occur in binary logic, also called machine logic. True-false logic, on which propositional logic is based, has an extra, you could say, dimension because of the possibility of true and false both being applicable. That does not make sense in our standard linear logic system, which is based on 0-1 logic, which, due to the presence of zero, is definitely linear. That's enough bracketing information. Our subject today is infinity. Because the overall theme in these broadcasts is astronomy, we will be angling toward astrophysics, where a certain form of infinity has definitely been encountered, where none was as clearly perceived before a century ago as is now perceived. In other words, the infinite extent of the universe. This is the first infinity that a human being encounters in their experience on this earth, a 3 trillion celled organism, a life form associated with this ecology limited to this planet as far as we can tell so far. This would be physical infinity. To outline how we're going to approach this fascinating topic, first of all, we will not be dealing with philosophy, or as it's called, where it impinges on science, metaphysics. Metaphysics has traditionally been part of what is called classical science, what used to be called natural philosophy. Up until the 19th century, natural philosophy was what science was called. We no longer call it that, partially for the reason that I just suggested, that metaphysics is somewhat removed now from science in comparison with its position 2 centuries ago and further back. In a modern approach to science, metaphysics is deferred, although it cannot be avoided. And the reason it's deferred is because of our increasing precision with numbers. This has a trade-off value in the way science is appreciated, understood, explained, assimilated, and known. Science morphs with time. It doesn't mean that science has changed ultimately. The goals remain the same. But the approaches, the methods, the various aspects of how we come to grips with reality is malleable. It's ductile. It has its own course that's associated with the course of human beings in their evolution, you could say, although of course not biological evolution. We're talking about actual evolution, something that's actually scientifically verifiable. Biological evolution, by the way, has been completely disproved. You may know that, but it's worth having some artillery in order to defeat any kind of suggestion that biological evolution is true or has a grain of truth in it. It has none. And the reason for that has finally been explained. And I recommend, in fact I insist, if you have any doubts about the veracity or validity of the theory of natural selection for biological evolution, according to what is generally accredited to Darwin, although it does not originate with Darwin, that theory has been fully exploded in a unique book, the last book of an author, an American author, by the name of Tom Wolfe. And if you've never heard of Tom Wolfe, it's because you are perhaps not interested in journalism. But in terms of journalistic prowess and accomplishment, no one really can hold a candle to Tom Wolfe, the author of The Right Stuff and the Electric Kool-Aid Acid Test, as well as several other books which became popular. He died within the past 6 years or so, but the last book that he produced was different from all of his other books. It was a book on Darwinism. And if you have any sympathy or any affiliation, any like for natural selection, biological evolution, then you must read Tom Wolfe's book, The Kingdom of Speech. The Kingdom of Speech. Tom Wolfe's last book, and by far his most important book, certainly in terms of science. It is remarkable that he was not a scientist, and that should tell you something about your ability and my ability to do science without a degree, without any background in the industry, simply using your brain correctly. You can be a scientist. Tom Wolfe was. He defeated the entire natural selection deception. Do not ever speak about natural selection except to say out loud that it is false. But evolution, disbarring the deception known as biological evolution, completely disproved, evolution as a principle is totally applicable to the human situation, the human equation as I call it. We do evolve. We evolve as individuals, and we evolve collectively. And the name of that game is called science. Science evolves. It has evolved. And in the past century, it has evolved so far that we have come in contact with infinity for the first time. Men have always known about infinity, and that's where I would like to begin. Infinity is first encountered by any human being in a very natural way, generally at a very young age. We all remember, and we can cause ourselves to remember if we don't clearly remember offhand, when we first looked into the night sky and wondered about the edge. That is infinity. Whatever infinity is, whatever it comes to be defined as, however it comes to be understood, the paradigm, the source of all conception of infinity, no matter whether it's mathematical, philosophical, excluding everything except religious, where anything goes. But in science, it's the opposite of religion, and it's not quite philosophy. Science is extraordinarily rigorous and needs to be what it is, which is what again? You should know by now what science is, according to the definition that I've given you, but I never assume that you've ever heard my voice before. So this is another golden opportunity to tell you point blank what science is. It's the process, broadly speaking, we'll call it simply the process of understanding what the universe says. What the universe says. To the degree that we add anything about what men say, it is to that degree not quite science. Science is the deduction of knowledge from interrogating the universe. And that's why we here, speaking for myself, but all of my listeners, perhaps now and perhaps in the future, we are interested in the universe. That is called astronomy. Not to go down that path and explaining exactly what astronomy is, we all know what it is. But in science, it's very important to spell out exactly what you mean. We won't go into that great detail now, although I have in prior lectures, about 300 lectures in 9 months, describing just what astronomy has found out. I call those the secrets of the universe, but the broad base of science goes all the way. It goes all the way to the human equation. It goes to the basic questions that human beings ask about reality. There is nothing more baffling in that respect than the subject of infinity. The way we all know about infinity together, such that we can even have a word for it, is based on our visual perceptual system, which is in the mind, but of course based in the body. Our bodies are here on earth, and we use our vision to look into heaven. We now call heaven the universe to get rid of the religious overtones, but for those of us who are fully mature, heaven is a perfectly reasonable term. We are human, don't ever forget that, but while we're scientists, we have to be rigorous. We have to be logical. We can only talk about those things which we actually know. And whenever we're forced or find ourselves in a situation where we have to mention something which is not perfectly known, perhaps it's theorized, but it's not actually proved, then we have to say, we must say, we're required by universal law to say that we don't know. And ordinarily, the word theory covers that. The theory of this or the theory of that is something you don't need to pay any attention to at all in science. We're not interested in theories. Theories are stopgaps for what we don't know. That is a natural cutting edge at all times. Why? Because science is progressive. So what we call the cutting edge, what I prefer to call the Fermi edge, because it's a bow shock analogy rather than a knife edge analogy, the Fermi edge of science is in all the newspapers every day. All over the internet. It's almost a rage. It's almost like the Beatles coming to America. The young girls screaming their lungs out with pleasure because of the Beatles. That is what the universe has become in science in the past century. It's the Beatles coming to town and driving us out of our minds with anticipation and wonder. The wonder of the beauty of the universe is something that a true scientist cannot get enough of. That is where I live. That's why I make these presentations. Today, we're going to define, fully explore, and completely understand infinity. This is a challenge that I did not think would come my way. I'm not an accredited scientist in the industrial sense. I did not go through the system except in the usual collegiate university sense. And I was employed by the industry, but only peripherally, as a database programmer and database manager. I'm a computer scientist, but that is not exactly a physicist. Physicists, in my opinion, are highly respectable people. They work very hard to attain their level of proficiency in their art. And science is an art as well as a discipline, like anything else that involves humans. Science is a wondrous gift that helps us as humans, if we choose to use it, to separate ourselves from the confusion of emotional life. We as humans cannot escape emotional life. It dominates us from birth to death. However, along the way, we discover that we have a rational intellect that was blueprinted into us just as surely as our endocrine system and our system of chemicals that powers our emotions, including anger, hatred, the negative emotions, pain. None of these are logical. Also love, faith, hope, those things that you find perhaps in your religion, are the common possession and inheritance of every human being that we will not escape, and we cannot cut ourselves off from our human origin. We do have to return to that when we're done with our science, either for a day or for a lifetime, we have to come back and face reality in the human sense. But while we're in science, we're logical. We're not completely human because we've cut off part of our humanity temporarily for the sake of the gifts of rational logic, which lead to truth. Truth has two forms. One of them is emotion-based. Love, don't ever forget, is an emotion. It is not logical. Love is irrational. That doesn't mean it's bad, obviously. It's the highest good for a human is love. We all agree on that. And now we enter the realm of pure logic. What can be seen and understood and communicated, not because we as humans feel like sharing, but because the universe says so. And that makes us authority figures. And we should be looked up to and respected, assuming we're doing our job. I intend to do my job, and I cannot speak for any other scientist in that respect. Each one of us, as we claim to be a scientist, is responsible for being where the buck stops. The final authority on anything scientific will be one human being. That could be you, that could be me, that could be Albert Einstein, that could be Brian Greene. Anyone is allowed to put on the robe and begin to speak on behalf of the universe, to tell other human beings what the universe says. But when you do so, you will be subjected. You will be subject to the laws of rational logic. And if some other scientist comes along who finds a flaw in your logic, you will suffer personally. It's not antiseptic. You're never aloof. You're not immune. You don't get a pass to say whatever you want in science. It's higher than any religion, because in religion, you can lie all you want, because no one can prove you wrong. But in science, if you make one little misstep, you will be destroyed. Eventually. It's quite sad that it takes a long time for some lies to be exposed. Lies cause damage, and deception is calculated damage. However, there's nothing anyone can do about that. This world is the way it is. But while I'm speaking, I will hold myself to account, and science will hold me to account as well. Currently, I have no connection with the body of science except by what I say. Nobody is required to believe me, and you should be grateful for that. Not because I intend to do anything underhanded, but because underhandedness is the rule of the game now in science. Those who are at the Fermi edge, who are studying astrophysics to reach the limits, are now talking about infinity. And you, of course, are aware of the quantum mechanical paradox. The wave-particle duality is most often how that is expressed. That is another form of infinity. We're going to be covering that today, And so let's get into it. This will be in the form of an outline approach to infinity. What is it? Generally in science, we prefer to begin with definitions. This is in order to have a playing field into which we all can come and know that we're safe with the definitions being established as the rules of order for the game. It is a game. We're trying to communicate. And that means there's a chance of miscommunication. Science intends to exclude that completely, so that what science says is absolutely true. That is an extremely lofty goal. But we have seen that science is successful in this endeavor. By adhering to the laws of rational logic, we have established a system as humans given to us. We've basically realized a gift that by using rational logic, we can communicate truth. The truth that the universe says. What the universe says. How will you know the difference between what the universe says and what some shyster is trying to pull over on you? How do you know? It's by executing the proof steps. There is always a proof underlying a true scientific statement. 1 + 1 = 2. That has actually been argued, believe it or not. But I think you see what I'm trying to say. We want to have not a theoretical definition of infinity, not an opinion, not a theory. We want the definition of infinity that the universe says. What the universe says is infinity is the only infinity that will ever matter. And that's the one we want. And by the end of this lecture, you will know what that is. And you will be able to follow the proof steps and verify for yourself what is infinity. The way I approach this subject at this time, the subject of infinity, is to divide it logically using a binary approach. It's a morphological system of class division to simplify the question. When done properly, the morphological approach yields the answer. There's no guarantee in any hypothesis or in any approach to reality that the system that you are using will be successful. The proof is in the pudding, and the pudding is in the proof. So let's begin. What is infinity? It's 4 things, and only 4 things. Infinity can be completely defined in 4 ways. That doesn't mean that all 4 are true. It means that there are 4 categories into which infinity must fit. And whatever it turns out to be that the universe says, we're going to have to begin with these 4 categories. That is my approach. Having said so, we're going to cover all 4 infinities so that you fully understand them. To a threshold. Understanding for a human is always to a threshold. What we're always trying to do in science is push the envelope. Push the envelope of understanding. We want a new threshold, a higher threshold of understanding. In this case, of infinity, which using my approach is one thing. There is one infinity that we will begin with in order to explore all four. So first I will name the four infinities, and then we'll begin with the one that's hierarchically at the top of the list. The four infinities, according to my morphological approach, are on a 2x2 grid, and I could have a diagram for that, but it won't be necessary, and it's better that we don't use a diagram. I'll be dealing with what's over here on this page towards the end of the lecture. The Planck constant, which is an approach to a definition of one of the four infinities that we need to name now. In two categories, infinity can either be physical or mathematical. So those are two columns, and now there are two rows. In the rows are outer infinity, which is the large infinity, the one that we're most familiar with, and in fact the one that we'll begin with. But there is a second infinity in both the mathematical and the physical category, and that is a tiny infinity. These have been given names both in the physical sense and in the mathematical sense. But the one we wish to begin with, in order to get a grip on all four kinds of infinity, we want to begin with the physical one going out. That is the one that every child encounters. It's the one that we can see to a threshold. It's the infinity of spatial extent. We call it the universe in this very specific sense, that it has an extent. This extent is ordinarily conceived to be spatial. Now you may be aware that Einstein has mixed space with time. We'll get there. Don't worry about time for now. We're talking about physical infinity, and time is a recent addition to the mix. However, it is worth mentioning, at least as a philosophical aside, that temporal infinity has always been contemplated by mankind. And that also has two aspects. Temporal infinity is the infinity of time. Well, time can be said to be bidirectional. Although it's oriented toward the future, we leave behind the past. So these two aspects characterize temporal infinity: an infinity past, perhaps, and an infinity future, perhaps. It's rather difficult to conceive of infinity future ever not being infinite. But that's philosophy, and we avoid that. We're not going to talk about time in this lecture. We're going to talk about spatial infinity, and that is physical. And there are two. Quantum mechanics has found an inner limit, but whether it's physical or not is still debatable. What is not debatable is the characteristic of the physical universe taken as a whole, that it has a spatial extent. We call it volume space. In other words, space that goes in all directions. We're not choosing any particular direction. A profound thing to say, by the way. You might want to give that some thought. Infinity is conceived to be the furthest extent of the universe But that raises a paradox, and that makes infinity ultimately unique among all the characteristics of physical space that we could name. Energy, matter, anything that we characterize that's in space, there is space itself, which has a very paradoxical aspect that we cannot see the edge. And more can be said there, and should be said. It's not just that we can't see the edge. It's that we cannot even imagine there being an edge. Because if there were an edge, by the definition of edge, there's something on the other side. And so infinity has an innately illogical aspect from our point of view as humans. And this has got to be accepted at the outset. Because if you imagine, or think that you can imagine, what infinity is, you are the first. You're the first person to do so. My intent is to lead you in the direction that perhaps you think you might already have reached, or that you think never can be reached. But science is about pushing the envelope. We now need, not just want. We must have some logical definition of infinity, or we simply will not understand the universe. But that's our goal. Here, that is our goal. So the four infinities are infinity in and infinity out, one of which is physical and the other is mathematical. We're going to deal with the mathematical aspect second. To begin with, we're going to deal with the physical infinities, and two of those have been discovered. These are progressive discoveries. Science is progressive, and certainly, in an approach to infinity, all results can only be characterized as an approach, because infinity has no definition. It simply cannot be defined. It's very much like division by zero, and we're going to get to that, because that is one of the mathematical infinities. In the physical realm, we discovered the inner infinity second. You must bear in mind that these are progressive discoveries, and so there is a bit of a fudge factor in order, so that it's somewhat ambiguous to say which one we discovered first, since technically we have not discovered either one yet. We know we don't have a definition of infinity. That's the subject of this lecture, is to get that definition. It can be done. I'm going to show you how. To do so, we begin with the infinity that we all agree on, which is a strange thing to say, because no one can define it exactly. And so it's the strangest term in all of science, in all of physics, is physical outer infinity. The full extent of the universe taken as a whole. Can that be measured? You may be aware, if you're listening to me in these lectures, or just this lecture for the first time, I would assume that you are aware that astrophysics has claimed to have a definition of infinity. We're not going to cover that here. Not right now, because it's dependent on a whole theoretical system called a model. But we don't wish to deal with something that intricate in an introductory lecture such as this one, which is intended for all age groups. You do not need to have a degree, nor do you need to have any mathematical capability at all in order to understand this lecture about infinity. Science is about communication to ordinary humans. It's not a secret language that requires calculus or supreme intelligence beyond the norm. Science is specifically defined as knowledge which is turned into understanding that can be shared among humans, period. There are a lot of footnotes. You're going to have a bit of difficulty sharing astrophysics with a 3-year-old or someone who's perhaps mentally incapacitated for whatever reason. Those people are in another category. That is not the decision of science to exclude anybody. Nature decides that. The question of inferiority or superiority of human beings comparing themselves with themselves is a matter of, it's not scientific. We do not rank each other. We do not lord it over each other. We're not trying to control each other. We're not trying to tell each other what to think. But scientists, among themselves, must do so. We must judge each other in our scientific ranks. With how capable are we of explaining what we know? That will be somewhat dependent on the audience. And I don't need to go into any detail or give you any examples of how in the highest ranks of science, the most palpable lies are often carried on for decades. It's part of the natural progress of science to overcome darkness, ignorance, stupidity, illogic. It's a fight. But fighting is illogical. We're forced to it in order to get the truth. We have to fight with each other. Why? Because of communication. Communication is a form of power. And if you can convince someone to believe you, you've got power over that other person, whether they sought it or not. We don't want that power. Power is for people who are interested in power. They're always among us, self-serving, selfish, greedy people. They exist in all walks of life, and there are scientists walking around right now who spout the most incredible illogic ever heard from the mouth of mortal man. We're not interested in that, nor are we interested in combating it. I am not here to fight, and a real scientist never is. That's why I don't really particularly like the reputation that Sir Isaac Newton has gotten, who was an irascible, power-hungry maniac in his own small way. For all my admiration of Newton as a scientist, I cannot overlook the fact that he accused Leibniz of stealing his calculus. Of all the infantile, unscientific, shameful stances to take, Sir Isaac Newton decided to become a pedant. We won't do that here. You don't have to believe me. I couldn't care less if you do or not. So why do I make these broadcasts? Because I've taken the vow of science. so that if I think that I know something, and I think that I've proved it, then I'm required to share it. I may be doing this against my will for all you know, but I'm not. I enjoy science. I hope you do too. We're here to have fun. So to begin with, we've covered the 4 basic types of infinity. 2 of them are mathematical, 2 of them are physical. The inner one in physics is the subject of quantum mechanics. We'll cover that second, and then we'll get to the mathematical infinities. But the primary one, the one we all know first, and the one that we want to get most, is the definition of physical outer infinity, the infinity of the universe. That's just one infinity. What do we know about it? Well, we can state the obvious, although it leads to a paradox that all children know. In fact, let's begin there. Remember, back when you were perhaps 10 years old, perhaps 7, perhaps 12, you're with your friends, and you're talking about the night sky that you have already seen. Every human being goes through this, so just recollect. What did you talk about with your mates about the universe that you saw past the stars? You looked at the stars, you saw that they're most likely very far away, and by the time you came to know that they are indeed very far away, the very first question that every child asks is, what is past the stars? When we did this, according to my own experience, we talked about the edge. Of course, every child does this. What is at the edge? Well, just so you know what our conclusions were as young incipient scientists, we decided, and my sisters agreed with this, what we all decided was at the edge of the universe was a brick wall. Now, we were not stupid, and I think the world over throughout time, no child is fooled by their first conclusion that there's a brick wall at the end of the universe. Because what's on the other side of the brick wall? And that's all we need to say. It's a paradox. If you can imagine the edge, then you have not imagined the edge yet. Because if you can imagine an edge, there's something on the other side. And that is something that no human mind has ever been able to rationalize. So, that is physical infinity going out. That which has no definition. But it does. It would have to, or we shouldn't even have a word for it, should we? How can we have a word for something that doesn't exist? Well, we do it all the time, not meaning to say that we're right or wrong about infinity, but there was a scientific proposition, a theory if you would, called, if I'm pronouncing it right, phlogiston. This was a substance that was considered to be the source of fire. Water has very little, if any, phlogiston. Now, just to make a long story short, I think you know what this analogy is meant to underscore. Phlogiston does not exist. If it did exist, it would have to be in the water, and we have actually taken water apart in the laboratory and found out that its 2 constituents, hydrogen and oxygen, are the 2 most explosive elements in the universe. Looked at one way, you could say that rather hyperbolically, but hydrogen, of course, is the source of the greatest explosion ever executed on Earth by man. And oxygen, we know, is pretty close to being phlogiston itself. You can't have fire, such as we know it, without oxygen. So the phlogiston substance was a hoax. It was a mistake. But it's all part of the regular advance of science. We have to make mistakes in order to make progress. What we don't want is to perpetuate mistakes once we know that they're mistakes. Because it has been said, rather nicely I think, that once you've eliminated all the things that are impossible, what you're left with is the truth. And in fact, that is the correct approach to the subject of infinity. Spatial infinity, spatial extent, volume extent, the extent of the universe to the edge is physical outer infinity. And we've come to 51 minutes now. This is a deep subject, but I wanted to get started on the right foot. There are 4 known infinities. These are categories. They're categorical infinities. Just to quickly, with one big, broad stroke, summarize the 4 infinities to characterize them in some way for the next lecture. The physical infinity going out is the paradigm for obvious reasons. It's the first one each of us encounters, in fact upon which all the others are based. The infinity that essentially we can see because we can't see it. We can't see the edge. We have not seen it yet, although in the next lecture I'll be covering for you some things you may already know, but it never hurts to summarize. The evidence that we have from astrophysics that there may be an edge. You may have heard of it. It's involved in what's called a model. There is a model of the universe that actually attempts to pinpoint the edge. You may have heard of it. It has a rather ludicrous name with the word bang in it and the word big. It would be a bang if they're right, and it would be very big. No other bang would be as big as that one if the model is correct. I will show you the flaw in that model. It's obvious. It's very much like phlogiston. But this has to do directly with infinity. And so this is the most important subject now in science. The topic of infinity. In mathematics, the problems that have been encountered with mathematical infinity are indescribable in their extent. The single most important problem science has ever faced is mathematical infinity. There are 2. The integral infinity, which is essentially what happens when you go to the end of the number line. There is no such thing, but since we know that there is no such thing, but it's unique, we give it a name. Infinity. But there's another one going in towards 0, and that's called the quantum limit. And those 2 infinities are geometrically related. That will be the key, but we don't begin with mathematics. We begin with physics. Because in the physical universe, it turns out there might be, I'll say it that way for now, that there might be an inner infinity. We call it, at this time, in particle physics, that is called the quark. And even that is not the full story, because there are two other particles, as they're called, which qualify as being involved with infinity. The quark is part and parcel of the infinity problem because the quark is in some way real, but it's also inside of the proton. And the proton is inside the nucleus. And the nucleus is inside the atom. And the atom is extraordinarily well understood now. We know its shape. We know its characteristics. We know virtually everything there is to know about the atom until you go inside. And there you encounter the electron. We're going to cover the electron in the next lecture and its role in our discussion of infinity. But the real infinity that all of the particle physicists are after is the one at the center of the atom. It took a long time to discover the center of the atom, and then we got inside and found two particles, the neutron and the proton. And inside of each of those is a subatomic, subnucleic particle called a quark. And nobody has ever figured out what the quark is. But somehow it's at the center of an atom because it's at the center of the nuclide, which refers either to the neutron or the proton. You may have heard of tinier particles that are called gauge bosons. And in fact, in that model, the photon is considered the gauge boson of electromagnetism. That's one way to model it, and it's the accepted way now. It takes a long time to come to grips with the logicality of that model. It definitely has its flaws, but it's reasonably good. It's not geometrically sound, however. It's mathematically very sound. But as for explaining anything, only geometry can do that. So that's our whirlwind tour for our opening lecture on this series on infinity. I promised by the end of this lecture to give you a solid grip on infinity. Obviously, that's going to be a phased introduction, but to close this out at exactly an hour, I want to give you something to think about. The physical infinity, which is at the edge of the universe, may or may not bound the universe. In other words, even though the universe looks like it's infinite, it might not be. It might be finite. But if so, obviously numbers are not going to help us. What will help us is geometry, because geometry deals not with numbers as such, but with numbers in their true role for understanding, which is as proportional quantities. Proportion is the way of the universe. So in terms of infinity, currently lacking a definition, but it has a bracketing definition that we're trying to narrow until we get it. That will be with geometry. It can be done, and I'll show you how. But I want you to think about whether or not the universe is finite. Don't expect to have a flash of insight, or if you do, I hope you can prove it. But I'll show you how to do this, how to get a correct apperception of infinity that's true. This is Anna Galactic bringing you the secrets of the universe. We're going to be talking about infinity in a way that I'm pretty sure you've never heard before. A way to understand it. Stay tuned. We'll be right back.